So let's talk a little bit more about energy. Remember that there is potential energy in many of our chemicals. And so foods are another thing that you're going to need to know about. There is potential energy stored in foods. Don't forget that energy is in kilocalories. On the labels, they try to tell you that because if you look at any food, it'll tell you how many calories with a capital C. Now, the energy in our food, the calories in our food comes from three big chemicals in our food: carbs, fats, and proteins. Every gram of protein is 4 calories. Every gram of carbohydrates is 4 calories, and every gram of fat is 9 calories. So we can use that and some math to calculate the energy in our food, like Cheez-Its. All right, so if you were going to have a serving of Cheez-Its, there would be 19 grams of fat, 19 grams of carbohydrates, 6 grams of fat, and 3 grams of protein. So how many calories in a serving of Cheez-Its? Well, we'd have to work out a little bit of math. And so our calories equal 6 times 6 grams of fat times 9 kilocalories, 19 grams of carbohydrates times 4 kilocalories, and 3 grams of protein times 4 kilocalories. Then we simply just work that out. 6 times 9 plus 19 times 4 plus 3 times 4. And we come up with 140 calories. Now, I guess technically I should have rounded that to one significant figure because that's what it should be with 6 grams of fat and 3 grams of protein, except for on the label it may say 6.0 or 3.0. I forget. All right, eggs. A lot of people eat eggs because they are supposed to have high protein. So if you have 2 eggs in the morning for breakfast, 156 kilocalories. If there are 10.6 grams of fat and 1.12 grams of carbohydrates, how many grams of protein? So if you want to try to set this one up, this may be a great time to pause this video and do that. All right, so 156 calories equals 9 times our grams of fat, 4 times our carbs, and 4 times our protein. And in this problem, we're not looking for our calories. We already know that. We're looking for our grams of protein. So we would put everything in, then work that out. 4 times our grams of protein. Then subtract 95.4 and 4.48 from the right side of the equation. Subtract them from 156 and we'd get 56.12 equals 4 times our grams of protein. Divide both sides by 4. And so there are 14.03 grams of protein in these 2 eggs. And so you do need to be able to do this and calculate the energy in food. Just another way to take a look at energy. Of course, we can also put food in a calorimeter and burn it to get the amount of energy in it. You'll need to be able to convert calories to joules. So if you had 140 calories, remember that's kilocalories, to kilojoules, you would convert it like this. Always start with your given. 1,000 calories in 1 kilocalorie. 4.18 joules equals a calorie. And then notice what's going to cancel out here. Kilocalories are canceled. Calories are canceled. Joules are canceled. And you get to kilojoules. And that equals 585. And of course, to put that in 2 significant figures, 590 kilojoules. So again, using dimensional analysis like we've been doing all semester. We also like to show the energy in a chemical reaction. So if we have a reaction going on with an energy diagram that looks like this. Now what this reaction shows, or what this diagram shows us, on the y-axis energy. So you can see low energy down here, high energy up here. and then time, over time. So if we start with a chemical reaction, like we had methane that we're going to burn, it would become carbon dioxide and water. Those are our reactants. That's what we start with at the beginning of this time, and those are our products. Notice our products have much lower energy than our reactants, but I mean, methane is combustible. It is flammable, so it does have high energy, and so does oxygen. Carbon dioxide and water are low energy. Now, in order to get that carbon dioxide and water to start doing something, we would have to do something to start them. That's called our activation energy. And then the amount of energy that they would put off is right here, between 45 and 10 kilojoules. So 35 kilojoules of energy released. So this would be exothermic. It would have a negative H value. Oftentimes, in between the reactants and products, the reactants may form an activated complex, and they often do that, sort of an intermediary thing that's super high energy, and it can't last. So again, I sort of think of this as the ball on the hill. Let me show you another one. Again, so exothermic, so energy is given off. Let's take a look at water. Water, again, would be low energy. And what we would have to do is push that water up this energy hill to get it to increase in energy. Now, we could do that with water, and they do that with water. We could simply take the water and pump it with electricity. We could put electricity into it, and then we would wind up with oxygen and hydrogen gas, which would be explosive and high energy. And so this is what an endothermic reaction looks like. Endothermic reactions are going to absorb energy. They're going to have a positive H value. All right, so see if you can remember what type of reaction is pictured here. Look at the reactants, look at the products. If you were thinking exothermic, you're exactly right. Your reactants started with higher energy than your products. How about this one? Hopefully you were thinking endothermic. Our reactants started with low energy and we had to push them up that hill.